In January of 2009, a research vessel was sailing through the freezing waters off Adelaide Island, Antarctica, hoping to document how killer whales hunt seals. The snow was falling thick and silent, the visibility poor, the sea grey and still. The team found what they were looking for: a pod of 10 orcas circling a large piece of ice where a Weddell seal lay stranded, its dark body pressed flat against the white surface. But they also found something they were not looking for. 2 humpback whales were in the middle of it, stationed between the orcas and the seal, and the orcas were agitated. At first, the researchers assumed the orcas were testing the humpbacks for weakness, probing them the way they probe any large whale to see if it might be sick, old, or travelling with a vulnerable calf. But when they reviewed the footage later, they saw something extraordinary. The seal was tucked between the 2 humpbacks. The whales were shielding it. The orcas circled and probed and eventually gave up, moving on to find another seal on another piece of ice. The humpbacks stayed where they were, with the seal still pressed against them until the danger had passed. This was not an isolated incident. It was not a fluke or a misreading of animal behaviour or a case of 2 large animals accidentally getting in the way. Over the following years, marine biologists began compiling reports of humpback whales intervening in orca hunts, and what they found was staggering in both its frequency and its implications. A comprehensive study published in Marine Mammal Science documented over 115 separate incidents spanning oceans around the world: Antarctica, the Pacific coast of North America, the waters off Australia, the open Atlantic. In these encounters, humpback whales actively approached hunting orcas, positioned themselves between the predators and their prey, and used their enormous bodies, their powerful tail flukes, and their deafening vocalizations to disrupt the kill. In some cases, they succeeded. The prey escaped, and the orcas went hungry. In others, they arrived too late, but stayed anyway, harassing the orcas for hours, sometimes abandoning prime feeding opportunities to do so, as if to register a protest against something they could not prevent, but refused to ignore. The prey they were defending included grey whale calves, harbour seals, California sea lions, Weddell seals, Steller sea lions, ocean sunfish, porpoises, and even the occasional smaller whale. In 89% of the documented cases, the animal being hunted was not another humpback. The humpbacks were saving strangers. No one can fully explain why. That is the question at the centre of this episode, and it is a question that reaches far beyond marine biology into the deeper territory of what animals feel, what animals know, and whether a creature with a brain the size of a basketball and a heart, the weight of a small car, can experience something that we, in our own species, would recognise as compassion. The humpback whale is one of the most studied animals on Earth. We know where it travels, what it eats, how it sings, how it mates, and how it raises its young. We know the chemical composition of its milk and the acoustic structure of its songs and the scarring patterns on its tail flukes that allow individual whales to be identified from photographs taken decades apart. But we do not know why it swims miles out of its way, abandons its feeding, risks injury from one of the ocean's most efficient predators, and places its body between a killer whale and a seal it has never met and will never meet again. Tonight, we are going to lay out everything we do know. about the humpback's mind, its body, its history, and its behavior. And then we are going to sit with the question that remains. Some mysteries are more interesting unsolved. The humpback whale sings. This is a fact so widely known that it has become almost ordinary, filed away alongside other nature trivia. Dolphins are smart, elephants never forget, humpbacks sing. But the ordinariness is a failure of attention because the humpback whale's song is one of the most complex and least understood acoustic performances in the animal kingdom, and the more closely scientists study it, the stranger it becomes. A humpback song is not a call. It is not a simple vocalization repeated on a loop, like the territorial cry of a bird or the alarm bark of a monkey. It is a structured, hierarchical composition, a sequence of sounds organized into units, which are grouped into phrases, which are grouped into themes, which are arranged in a specific order to form a song that can last anywhere from 7 to 30 minutes, and which the whale will then repeat, sometimes for hours, sometimes for days, hanging motionless in the water column, with its head angled slightly downward, broadcasting at frequencies and volumes that can carry across entire ocean basins. The sounds themselves range from deep, resonant moans to high-pitched cries and eerie, wavering wails that have no equivalent in any other animal's vocal repertoire. Listening to a humpback song in the water is, by the accounts of divers and researchers who have experienced it, profoundly unsettling and profoundly beautiful. A sound that is clearly structured, clearly intentional, and completely alien. Only males sing, and they sing primarily during the breeding season on or near the tropical breeding grounds where humpbacks gather each winter after completing the long migration from their feeding areas near the poles. The purpose of the song is almost certainly related to reproduction, though whether it functions as a courtship display aimed at females, a competitive signal aimed at rival males, or something else entirely remains unresolved. What is resolved, and what makes humpback song genuinely extraordinary, is that it changes. Every male in a given breeding population sings essentially the same song at any given time, but the song evolves over the course of the season. New phrases are introduced, old phrases are modified or dropped, and the overall structure shifts gradually, so that the song being sung at the end of the breeding season is measurably different from the song being sung at the beginning. The following year, the males pick up where they left off, continuing to modify the song from its most recent version. Over the course of several years, the song can change so completely that it bears no resemblance to the version from a few seasons earlier. The changes are not random. They spread through the population in a pattern that implies social learning. One whale introduces a new element and other whales adopt it, modifying their own songs to incorporate the innovation. In the South Pacific, researchers have tracked song changes rippling westward across breeding populations, from eastern Australia to New Caledonia to Tonga to the Cook Islands, a cultural wave travelling thousands of kilometres across the ocean over the course of 2 to 3 years. Occasionally, the change is not gradual but revolutionary. An entirely new song appears and replaces the old one within a single season, sweeping through the population like a hit single, displacing last year's chart topper. This is cultural transmission, the passing of learned behaviour from one individual to another. And it is one of the clearest examples of non-human culture ever documented in any species, terrestrial or marine. The humpback whale does not simply make noise. It composes, it learns, it teaches, and it participates in a musical tradition that spans generations and ocean basins. Whatever else the humpback is, it is not a simple animal operating on instinct alone. Its brain is doing something complex, something creative, something that looks very much like what we would call art if a human were doing it. Every year, humpback whales undertake one of the longest migrations of any animal on Earth, a round trip that can exceed 16,000 kilometers, from the cold, nutrient-rich feeding grounds near the poles to the warm, sheltered breeding grounds in the tropics and back again. The migration is driven by two competing biological imperatives that cannot be satisfied in the same place. Humpbacks feed in cold water, where upwelling currents bring nutrients to the surface and sustain the dense concentrations of krill and small fish that the whales depend on. But they breed and give birth in warm water, where the calves, born without the thick blubber layer that insulates adults, have the best chance of surviving their first weeks of life. The result is a life spent in constant transit, an annual cycle of gorging and fasting, cold and warm, abundance and scarcity that has shaped every aspect of the humpback's biology. The feeding season is intense. In the waters off Alaska, Antarctica, Iceland and Norway, humpbacks spend the summer months eating almost continuously, consuming up to a ton of food per day and building the fat reserves that will sustain them through the months ahead. They do not eat on the breeding grounds. For the duration of the migration south and the weeks or months spent in tropical waters, the whales live entirely off their stored blubber, slowly burning through the energy they accumulated during the summer. A lactating female, producing milk that is roughly 35% fat, one of the richest milks of any mammal, burns through her reserves even faster, losing as much as 1/3 of her body weight over the course of the breeding season. The cost of migration is enormous, and it falls disproportionately on mothers, who must fuel both their own bodies and the rapid growth of their calves on reserves that are finite and shrinking. The navigation involved in this migration is not fully understood. Humpbacks travel along routes that are remarkably consistent from year to year, arriving at the same feeding and breeding areas with a precision that suggests a sophisticated navigational system, but the mechanisms underlying that system are still debated. Some researchers believe humpbacks use the Earth's magnetic field as a compass, detecting the faint magnetic gradients that vary with latitude and longitude. Others have proposed that they navigate by the position of the sun or stars, or by following large-scale ocean currents, or by using acoustic landmarks. The sounds of particular coastlines, seamounts, or biological communities that create recognizable sonic signatures in the deep sound channel. The truth is probably a combination of these, a multimodal navigational toolkit assembled over millions of years of evolutionary refinement, but the details remain elusive. What is clear is that humpback calves learn the migration route from their mothers, following them on the first journey north and then repeating the route with remarkable fidelity for the rest of their lives. The road is not written in the genes. It is taught. This fidelity to learned routes has a consequence that matters for our story. Because calves return to the feeding and breeding grounds of their mothers, humpbacks in a given area tend to be more closely related to one another than to the population as a whole. The whales that feed together in a particular bay off Alaska or breed together on a particular reef off Hawaii are often kin. Mothers and daughters, cousins, half-siblings. This means that when a humpback hears orca hunting calls in its home waters, the animal being attacked may well be a relative. The impulse to intervene may not be as selfless as it appears. It may be kin selection dressed in the clothing of altruism, a gene looking after copies of itself in other bodies, or it may be something else entirely. We will come back to this question, but first, we need to understand what the humpback is protecting and what it is willing to risk to do so. A humpback whale calf is born in warm tropical water after a gestation of roughly 11 months. It arrives tail first, a streamlined bundle of dark skin and pale belly markings, roughly 4 meters long and weighing around a ton, large by the standards of most animals, but small and fragile by the standards of its mother, who may be 14 meters long and weigh 30 tons. The calf cannot breathe underwater. Its first act in the world is to swim or be nudged by its mother to the surface, where it takes its first breath of air, filling lungs that will carry it through dives lasting up to 20 minutes as an adult, but that, for now, can manage only a few minutes at a time. The calf is entirely dependent on its mother. It will nurse for at least 6 months and sometimes longer, consuming over 200 litres of milk per day. Thick, fatty, yellowish milk with the consistency of yogurt. And it will remain close to her for a year or more, learning the migration routes, the feeding techniques, and the social behaviours that it will carry for the rest of its life. The bond between a humpback mother and her calf is one of the strongest and most enduring in the animal kingdom, and it is the foundation on which the humpback's entire social world is built. It is also the bond that orcas exploit. Humpback calves are among the preferred targets of mammal-eating orca populations worldwide. The calves are slow, relatively small, and incapable of the sustained diving that adults use to evade predators. An orcapod hunting a humpback calf will typically attempt to separate it from its mother. Driving between the pair, harassing the mother from multiple directions, and wearing down the calf until it is too exhausted to keep up. The attacks can be relentless, lasting hours, with the orcas working in coordinated shifts, some animals engaging the mother while others focus on the calf. The mother fights back with everything she has. She positions her body between the calf and the attackers, rolls on her side to shield the calf beneath her massive pectoral fin, slaps the water with her tail flukes to create shock waves that drive the orcas back, and bellows at volumes that can be heard for miles. These battles can last for hours, and they do not always end well. Studies of humpback populations in breeding areas have found that between 11 and 20% of adults and calves bear rake-mark scars from orca teeth, parallel lines scored into the skin, evidence of attacks that the whale survived but did not escape unscathed. Some calves do not survive at all, and the loss of a calf represents years of invested energy for a mother who may not reproduce again for another 4 to 20 years. The ferocity of a humpback mother's defense of her calf is not unusual in the animal kingdom. Many species fight to protect their young. What is unusual is what happens next. What happens when the animal under attack is not her calf, not a relative, not even another humpback? The maternal defense instinct in humpbacks appears to be so powerful, so deeply wired into the animal's behavioral repertoire, that it can be triggered by the sound of orca hunting calls alone, regardless of what species is being hunted. A mother who has spent weeks or months defending her calf from orcas, who has learned to associate the sounds of orca predation with an immediate threat to her offspring, may be neurologically primed to respond to those sounds with aggression, charging toward the source, interposing her body, tail slapping and bellowing, before she has any information about what the orcas are actually attacking. By the time she arrives and discovers that the prey is a seal or a sunfish or a grey whale calf, she is already committed. And remarkably, she does not leave. She stays and she fights for an animal that is not her own. The question is whether she stays because she cannot override the instinct that brought her there, or because she chooses not to. The humpback whale does not hunt the way most large predators hunt. It does not chase individual prey items through the water, relying on speed and agility to run them down. It is a filter feeder. It engulfs enormous volumes of water and the small organisms suspended in it, straining the water out through its baleen plates and swallowing the concentrated mass of krill or small fish that remains. This sounds simple, and in its most basic form, it is. The whale opens its mouth, lunges forward, and takes what it gets. But humpbacks have developed a feeding strategy so complex, so coordinated, and so clearly the product of learning rather than instinct that it has become one of the most studied examples of cooperative behavior in any non-human animal. It is called bubble net feeding, and it is a masterpiece of applied intelligence. The technique works as follows. A group of humpbacks, typically between 2 and 15 individuals, locates a school of fish or a dense aggregation of krill near the surface. One whale, sometimes called the caller, begins producing a specific vocalization, a loud, eerie, trumpeting cry known as the feeding call, that appears to serve both as a signal to the other whales and as a stimulus that frightens the prey into a tighter aggregation. Simultaneously, one or more whales dive beneath the prey and begin swimming in a spiral, releasing a steady stream of bubbles from their blowholes as they ascend. The bubbles rise in a cylindrical curtain, the bubble net, that encircles the prey school, creating a wall of visual and acoustic disturbance that the fish or krill will not cross. The diameter of the net, the speed of the spiral, and the rate of bubble release are all precisely calibrated to the size and density of the prey school. Too large a net, and the prey disperses before the lunge. Too small, and not enough prey is captured to justify the energy expenditure. The prey is trapped inside the net, concentrated into an increasingly dense ball as the spiral tightens. Then, on cue, triggered by the feeding call or by some other signal that researchers have not yet identified, the whales lunge upward through the center of the net with their mouths agape, their throat pleats expanding like an accordion, engulfing the entire concentrated prey ball in a single explosive surge that can capture hundreds of kilograms of food in a matter of seconds. The coordination required is extraordinary. Each whale in the group has a specific role: the bubble blower, the caller, the herders that maintain the net's integrity, the lungers that time their ascent to coincide with the moment of maximum prey density. The roles are consistent from one feeding event to the next, suggesting that individual whales specialize in particular tasks and that the group functions as a practiced, rehearsed team. Young whales learn bubble net feeding by observing and participating alongside experienced adults, and populations that have never been exposed to the technique do not spontaneously invent it. It must be culturally transmitted, taught from one generation to the next, in a chain of social learning that may stretch back thousands of years. Bubble net feeding tells us something important about the humpback mind. It tells us that humpbacks can plan, coordinate, communicate, and execute a multi-step strategy that requires each participant to subordinate its individual impulses to the timing and needs of the group. It tells us that they can learn complex behaviors from one another and maintain those behaviors across generations. And it tells us that the humpback's capacity for cooperation is not limited to the protection of offspring. It extends to feeding, to social bonding, and to the kind of collective action that, in human societies, we would call teamwork. An animal capable of bubble net feeding is an animal capable of complex social cognition. And an animal capable of complex social cognition is an animal that might, just might, be capable of something resembling a decision when it hears orca hunting calls and swims toward the fight instead of away from it. To understand why humpback whales intervene in orca hunts, you must first understand the predator they are confronting. The orca, the killer whale, though it is technically the largest member of the dolphin family, is the most formidable marine predator on Earth. It is not the largest, and it is not the strongest in any simple mechanical sense, but it is the most intelligent, the most adaptable, and the most socially coordinated. And those qualities, combined with a body that can weigh 11 tons and swim at speeds exceeding 30 miles per hour, make it effectively unchallenged at the top of the marine food chain. Orcas kill great white sharks. They kill blue whale calves, the offspring of the largest animal that has ever lived. They kill sperm whales, grey whales, and minke whales. They kill humpback whale calves. And they do it not through brute force alone, but through strategy, through plans that are conceived, communicated, and executed by groups of animals working together with a precision and a flexibility that has no parallel among marine predators and few parallels among terrestrial ones. Orcas are not a single homogeneous species. They are divided into ecotypes, genetically and culturally distinct populations that specialize in different prey and use different hunting techniques. In the waters of the Pacific Northwest, resident orcas eat fish, primarily salmon, and hunt using echolocation to locate individual fish in the water column. They are vocal, social, and relatively approachable. Transient orcas, also called Biggs orcas, eat marine mammals. They hunt in silence, communicating through subtle body language and occasional quiet clicks, because their prey, seals, sea lions, porpoises, and whales, can hear them. A transient orcapod approaching a haul-out of harbour seals moves with the discipline and stealth of a special operations team. Each member positioned to cut off escape routes, each one waiting for the coordinated rush that will drive the prey into the water and into the jaws of the others. In Antarctica, the B1 orcas have developed a hunting technique found nowhere else on Earth: wave washing. When the orcas locate a seal resting on a small ice floe, they line up in formation, side by side, bodies synchronized, and swim toward the floe at speed, creating a wave that washes over the ice and sweeps the seal into the water. The technique requires precise coordination, exact timing, and an understanding of fluid dynamics that the orcas could not have arrived at through instinct alone. Calves learn wave washing by watching their mothers and practicing on empty ice floes, sometimes for years, before they are proficient enough to participate in an actual hunt. This is culture, learned, transmitted, refined over generations. And it makes orca hunting not merely effective, but adaptive, capable of evolving in response to new prey, new environments, and new challenges. It is this predator, this intelligent, coordinated, culturally sophisticated predator, that the humpback whale confronts when it intervenes in a hunt. The humpback is larger, sometimes twice the length and several times the weight of an individual orca, and its tail flukes and pectoral fins can deliver blows powerful enough to injure or kill. But it is slower, less maneuverable, and it is alone against a coordinated group. The humpback has no teeth, no claws, no venom. Its only weapons are its size, its stubbornness, and a willingness to put itself between a killer and its prey and refuse to move. That this strategy works, that it succeeds often enough to be worth the cost, tells us something remarkable about the balance of power between these two species. The orcas could, in theory, overwhelm a single humpback if they committed fully to the attack, but they rarely do. The orcas are pragmatists. Every calorie spent fighting a 40-ton adversary that refuses to flee is a calorie not spent hunting something easier. And the cost-benefit calculation tips in favor of finding prey that does not fight back. And the humpback, apparently, knows this. Now we come to the behavior itself. The act that has puzzled marine biologists, captivated the public, and resisted easy explanation for as long as it has been observed. Humpback whales disrupt orca hunts. They do it frequently. They do it across every ocean where the two species overlap. And they do it with a consistency and a determination that rules out coincidence. The study that brought this behavior to wide scientific attention was published in 2016 by Robert Pittman, a marine ecologist with the National Oceanic and Atmospheric Administration, and his colleagues. Pittman's team compiled and analysed 115 interactions between humpback whales and mammal-eating orcas, drawn from decades of field observations, published reports, and first-hand accounts from researchers around the world. The findings were remarkable, and they have only been reinforced by subsequent observations. In 57% of the documented cases, the humpback whales initiated the encounter themselves. They were not already present when the orca hunt began, but actively travelled to the scene, sometimes from distances of 2 or more kilometres, after apparently detecting the sounds of the hunt. Orcas that specialise in hunting marine mammals are silent during the stalk, but become highly vocal once the attack begins, and humpbacks appear to recognise these predation calls and respond to them with a directional, purposeful approach. The humpbacks arrive at the scene and immediately engage, positioning themselves between the orcas and the prey, slapping the water with their tail flukes and pectoral fins, rolling on their sides to present the maximum possible physical barrier, and producing loud, low-frequency vocalizations that can be heard at great distances. In some cases, multiple humpbacks converge on the same hunt from different directions, creating a defensive perimeter around the prey that the orcas cannot easily penetrate. The physical tactics are varied and appear to be situationally adapted. Humpbacks have been observed using their pectoral fins, which can be 5 meters long, the longest limbs of any animal on Earth, to sweep orcas away from a prey animal. They have been observed rolling onto their backs and allowing prey animals, including seals and sea lions, to rest on their upturned bellies, lifting them out of the water and beyond the reach of the circling orcas. In one widely reported incident in Antarctica, a humpback used its flipper to nudge a Weddell seal farther onto its chest after the seal began to slide off, an act that is extremely difficult to explain as anything other than deliberate. In Monterey Bay, California, in 2012, a pod of orcas killed a grey whale calf after a prolonged attack. 16 humpback whales arrived over the following hours, not to save the calf, which was already dead, but apparently to prevent the orcas from eating it. One humpback stationed itself beside the carcass and remained there for 6.5 hours, tail slapping and vocalizing every time an orca approached to feed. The humpbacks ignored a massive krill bloom in the immediate vicinity, abandoning a prime feeding opportunity to harass predators over a carcass that was of no value to them. The cost of these interventions is not trivial. Humpbacks that travel kilometers to reach an orca hunt are burning energy they cannot easily replace, particularly during the breeding season when they are already fasting. The confrontations themselves can last for hours. The Monterey Bay incident lasted 6.5 hours, and other documented encounters have lasted as long as 7. During these encounters, the humpbacks are engaged in intense physical activity, swimming at high speed, tail slapping, rolling, and maneuvering that demands significant caloric expenditure. There is also a real risk of injury. Orcas possess large, interlocking teeth and are capable of inflicting serious wounds, and while a healthy adult humpback can generally fend off an orcapod, the risk is not zero. Rake marks from orca teeth are found on the flukes and flippers of many adult humpbacks, and some of these scars may have been acquired during intervention events rather than during attacks on the humpbacks themselves. The humpbacks, in short, are paying a real price in energy, in time, in risk, and in the vast majority of cases, the beneficiary of that price is an animal of a completely different species. The range of species that humpbacks have been documented defending is striking in its breadth. The list includes grey whale calves, minke whales, California sea lions, harbour seals, Weddell seals, crab-eater seals, Steller sea lions, ocean sunfish, and at least one species of porpoise. There is no common thread connecting these species, except that they were all being attacked by orcas at the moment the humpbacks arrived. The humpbacks do not appear to discriminate. They respond to orca hunting activity regardless of what the orcas are hunting. In Pittman's study, only 11% of the documented interventions involved orcas attacking another humpback. The other 89% involved the humpbacks defending prey species with which they have no social relationship, no ecological connection, and no genetic overlap. Whatever is driving this behavior, it is not species recognition. It is something broader, something triggered by the act of predation itself, by the sounds of a hunt, by the sight of a struggle, by some stimulus that the humpback's nervous system interprets as a reason to act. Why do they do it? This is the question that has generated the most debate. the most speculation and the least consensus among the scientists who study humpback whale behavior. Several hypotheses have been proposed, and none of them is entirely satisfying. The most parsimonious explanation, the one that requires the fewest assumptions about the humpback's inner life, is the misdirected defense hypothesis. Humpback calves are frequently targeted by orcas, and a humpback that responds aggressively to orca hunting calls is protecting its own species, or potentially its own kin, in a meaningful percentage of cases. If the behavior evolved because it benefits humpbacks when the prey is a humpback calf, the fact that it also fires when the prey is a seal is simply a side effect. A false alarm that is tolerated because the cost of intervening unnecessarily is lower than the cost of failing to intervene when it matters. This explanation is clean, and it is consistent with evolutionary theory. But it has a problem. Humpbacks do not leave when they discover the prey is not a humpback. They arrive, they assess the situation, and they stay. They stay for hours. They stay through krill blooms. They stay when the prey is already dead. The misdirected defense hypothesis predicts that a humpback would disengage once it realized no humpback was at risk. The humpbacks do not disengage. Robert Pittman, who coined the term inadvertent altruism to describe this behavior, has acknowledged this difficulty. The behavior looks less like a misfiring instinct and more like a choice, a decision made in the moment to continue fighting for an animal the humpback has no biological reason to protect. Is it empathy? Some researchers think so. Humpback whales possess spindle cells, specialized neurons found in the anterior cingulate cortex and frontoinsular cortex of the brain, regions associated in humans with social cognition, emotional processing, and empathy. Spindle cells were once thought to be unique to humans and great apes, but they have since been found in several cetacean species, including humpbacks, and their presence suggests that humpbacks may have the neural hardware for complex emotional experience. This does not prove that humpbacks feel compassion. Neural hardware is not the same as subjective experience, and the leap from brain structure to emotional life is one that science cannot yet make with confidence for any non-human animal. But it is suggestive. It tells us that the possibility is real, that a humpback whale swimming toward the sound of a hunt may experience something when it arrives and sees a seal struggling in the jaws of an orca. Something that makes it stay. We end not with an answer, but with a larger question, a question that the humpback whale's behavior opens, but that extends far beyond any single species. What is a mind? What does it mean to be conscious, to be aware, to feel? These are questions that philosophy has struggled with for millennia, and that neuroscience has only recently begun to address with any empirical rigor. For most of human history, the answer was simple. Minds belong to humans. Animals act on instinct. They do not think, they do not feel, they do not make choices. Descartes called them automata, biological machines responding to stimuli with no inner experience, no subjective awareness, no sense of self. This view held sway for centuries, and it was convenient because it freed human beings from any moral obligation toward the animals they hunted, farmed, and slaughtered. The humpback whale makes this view very difficult to maintain. Here is an animal that composes songs and modifies them over time, participating in a musical tradition that spans ocean basins. That learns migration routes from its mother and teaches feeding techniques to its young. That coordinates complex group behaviors. Bubble net feeding, cooperative calf defense, requiring planning, communication, and role specialization. That possesses a brain with the same specialized neurons found in the regions of the human brain associated with empathy and social cognition. And that, on 115 documented occasions, and almost certainly many more that were never witnessed, has swum toward danger to protect an animal of a different species from a predator, incurring real costs in energy, time, and physical risk, with no apparent benefit to itself or its kin. None of this proves consciousness nor empathy. But it makes the alternative, that the humpback is an automaton, a machine responding to stimuli with no inner life, no awareness of what it is doing or why, increasingly implausible and increasingly difficult to maintain without willful blindness. The Cambridge Declaration on Consciousness, signed in 2012 by a group of prominent neuroscientists, stated that the weight of evidence indicates that non-human animals, including all mammals and birds, possess the neurological substrates that generate consciousness. The declaration did not single out whales, but its implications for cetaceans are significant. If mammals possess consciousness, then humpback whales, with their enormous, complex brains, their cultural behaviors, their social bonds, and their apparent capacity for interspecific altruism, are among the most likely candidates for a rich inner life. We cannot know what a humpback whale experiences when it hears the sound of an orca hunt and turns toward it. We cannot ask, and the whale cannot tell us, but we can observe what it does. And what it does, consistently, repeatedly, across oceans and across decades, looks less like a reflex and more like a decision. A decision to intervene, a decision to help, a decision that costs something and that benefits someone the whale has never met. The ocean is full of intelligence. It always has been. We are only now beginning to develop the tools and the humility to recognize it. The humpback whale is not the only mind in the water. The orca is brilliant. The sperm whale communicates in coded dialects. The octopus solves problems with a nervous system distributed across 8 arms. But the humpback may be the animal that forces us to confront the most uncomfortable question of all. Not whether animals think, but whether they care. And if they do, if a whale can feel something like concern for a seal it has never met, then what does that say about the way we treat the ocean and everything in it? A humpback whale hears the sound of a hunt and turns toward it. It does not know what is being killed. It does not know whether the victim is kin or a member of its own species, or a stranger of a kind it has never encountered before. It only knows the sound, the vocalization of orcas in the act of killing, and it responds. It swims, it arrives, it puts its body between the hunter and the hunted, and it stays. We do not know why. We may never know why, not fully. Not in the way we know why a reflex fires or a hormone surges. But we know what it looks like. It looks like a choice. It looks like an animal that has decided that the death happening in front of it is something worth opposing, even at a cost, even for a stranger. And if that is what it is, if somewhere in that enormous brain, behind those calm, dark eyes, something stirs that resembles what we call compassion, then the humpback whale is not just one of the largest animals on Earth. It is one of the most remarkable. and the ocean it swims in is a more interesting place than we ever imagined. Sleep well tonight. Somewhere out there, in the dark water, a humpback is listening, and if it hears something it doesn't like, it will go. Thank you for listening.